Now to graph some square root functions, but before we do, let's take a look at our functions and let's kind of go ahead and describe what kind of transformations we're going to see and how these transformations may affect our domain and our range. And so we're dealing with square root functions. So we start off in the parent form where it's the square root of x, where our domain is greater than or equal to 0, and our range is greater than or equal to 0. But with these transformations that we see, we got some changes here. So first off, let's deal with our domain, and I'm looking underneath the radical, and we're going to set this x plus 4 such that it is greater than or equal to 0, so that x must be greater than or equal to negative 4. And so my domain, in describing it, then we're going to say domain is x such that x is greater than or equal to negative 4, because we can't take the square root of a negative number. Now I don't have any vertical shift out here. This 4, by the way, is going to give us a horizontal shift to the graph of the square root function 4 units to the left. But my range is still going to be, in this case, and we're going to use f of x here, so that f of x, or y, such that f of x is greater than or equal to 0. And this 2 here is going to give us a, what's the right word? Oh, a dilation. A dilation, it is going to stretch this function vertically by 2 units. Now, in our second function, we got f of x equals 1/4, the square root of x minus 5 plus 3. And again, let's go ahead and set our domain. We're going to set this up. We're going to deal with what's underneath the radical. We're going to set that equal to greater than or equal to 0. So that x must be greater than or equal to 5. That would prevent us from taking the square root of a negative number. So our domain then is going to be equal, let's set a little mark right there, to x such that x is greater than or equal to 5. Now our range has been affected. We got a transformation on the range because this plus 3 is going to give us a vertical shift. So that we got f of x such that f of x must be, or is going to be, greater than or equal to 3. It's going to shift it 3 units up. The negative 5 in there is going to shift our function 5 units to the right. And this 1/4 here, this dilation, is going to compress. It's going to push this thing down closer to the x-axis by a rate of 1/4. So now we're going to go over to the calculator and we're going to graph these two functions alongside, I'm going to do it alongside the parent function so that we can see the effect of these transformations. All right, we're over here on the calculator. I'm sitting here in y equal. I first want to graph the parent function of this. So I'm going to hit second square root, or x squared, second x squared, which gives me the square root function. And I'm just going to put in x. And let's see, now I'm going to graph what our first example was, which was 2 times the square root of x plus 4. And we're going to clear the radical. And let's take a look at the graph of these two. So in the blue, you see the parent function, where the domain and the range both are such that it is greater than or equal to 0. And with our domain, the same holds true with the red graph, which is our parent. Well, no, not the same. As our domain must be is greater than or equal to negative 4. That plus 4 in the underneath the radical gave us a horizontal transformation of 4 units to the left. And we see that 2 stretched this graph vertically. Let's go and just take a quick peek at the table. And I can see the difference here. Let's move this. We'll move this more towards. You can see there in y1 in the parent function, once x goes negative, we have an error. That's telling us a restriction to the domain. And once we get past -4, we see that error show up in y2. And then we've got this transformation of 4 units to the left. Now let's go to graph the second function. I'm going to leave the parent alone. But in y2, I'm going to change this to 1/4. And I'm going to use 0.25 for 1/4 decimal. 0.25, same thing as 1/4, times the square root of, what was it, x minus 5. That's going to give us a transformation of 5 units to the left. And then we had a vertical shift of +3. So once again, the blue graph is going to be the parent, and the red graph is going to be the transformation. So I see that I've moved 5 units to the left. That means my domain has been restricted so that x must be greater than or equal to 5. I've got a vertical transformation where my range has changed now, where it must be greater than or equal to 3. And that 1/4, you can see this is almost flat, the red one is. And it is pushing it down towards the x-axis, that dilation, another type of transformation. All right, have fun.